The shell method, example 2. We have the same region that was presented in problem 1 or example 1. What changes for example 2 is now I want to go about the line x equals 6. So it's parallel to the y-axis. So let me redraw the graph real quick. We start with our parabola that was 3 units up and it was opening downward. So here's my vertex. I go right 1, down 1, right 2, down 4. Second curve is a line. Starts one unit beneath the origin. Has a slope of 3. Up 1, 2, 3, right 1. Gives me that point of intersection of 1, 2. And x equals 0 is the y-axis. So we are referring to this little region, this triangular region right here that has some curve to it. That's what we want to revolve, but this time we want to revolve it about the line x equals 6, which is parallel to the y-axis. With the shell method, you have to be egocentric. So we'll set this up. We're going to do our volume. We know it has to be a 2 pi. We have to have a radius, we have to have a height, and we have to have a dimension, a depth. That dimension is always going to be the opposite of your axis of revolution. So if this is y-axis, I expect dy. This is parallel to the y-axis, so I still expect dy, but with shell, we're going to go to dx. It's always reversed. Y-axis will be a dx. So since it's a dx, it tells me I can go integral from x equals 0 to x equal 1. That's the region I'm referring to on the x-axis. X equals 0. That always has to match your dy or dx. X's and x's, y's and y's. So x equal 1. 2 pi. If you would like to pull your 2 pi out of the integral, you're more than allowed to do that. You're more than welcome to do that. I like to keep them in there. Everybody's a little bit different. Now, as we get to the radius, our perspective will change with this problem because you are egocentric. You have to be, with the shell method, situated at your axis of revolution. So you're at 6. I'll put a 6 right there. And then in order to get to my region that's being revolved, to get to these heights, I have to move to the left. And so this would be 6 minus x. To go this direction, it would have to be a minus x. My radius for this problem will be defined as 6 minus x. I was at 6. I'm moving to the left, so that would be a minus x. If the region would have been over here that was being revolved, if I had some shape over here, it would have been 6 plus x to get me over to that region. Okay, so I'm at 6 minus x, and then the height, well, the height is going to be that parabola minus the line. And since I did that in example 1, I'm going to just recycle that part. It's going to be negative x squared minus 3x plus 4. That was my defined height, dx. And then, I don't want to do this with every example, but just to reinforce what we've said a few times already in previous problems. Notice that when you draw your picture, this picture is being revolved. It's three-dimensional, huge region here. That is not going to be what you see on your calculator. My calculator is going to set up this as an area. And obviously I have 3 dimensions. I've got a radius, a height, and a dx. 1, 2, 3 dimensions. A calculator is going to represent that volume as an area. So I'll type this in. I'll go 2 pi times parenthesis 6 minus x, close parenthesis, times parenthesis negative x squared minus 3x plus 4. And then I'll do my zoom 6. What I'm interested in is this region from 0 to 1. So I'll go second, calc, option 7. I'll start at 0, it asks for a lower limit. Then it asks for the upper limit, I'll end it at 1, and it will shade that in. Now that's given me an area, but it's actually reporting this as a volume because of the way I set this up. Your calculator is only as smart as you are. So my volume for this particular problem was 76.969 units cubed. And that would be our shell method, example 2, where we do the 2 pi r h d opposite of whatever your axis of revolution is. Y-axis, you go do dx. X-axis, you go dy. Shell method, example 2.